Welcome to the Azure podcast. This is episode 505, being recorded on Friday the 13th, 2024. I'm Russell Young, and co-hosting with me today are Cale and Cynthia. And a very warm welcome to our guest today, Willie Ahlers, who's a principal architect in the cross-industry solutions team. We're going to be talking about the topic of the day, which is AI route to live, and we'll dig into that after our regular round of Azure updates. So, Cale, I noticed you put a couple in there, and we've already been chatting a little bit about one of the first ones that you've got in there. Do you want to kick off with that?
Yeah, sure. I got two in here today. One of them was just published here recently, and it's around another. I think we need to have an acronym for these. Yet another AI model. But yeah, this is introducing the O1. I guess that's the way you pronounce that model. Basically, it's a new AI model for reasoning. That's being used for developers and enterprises in Azure. And so basically, we have this O1 preview and O1 mini that are now available in our platform. And essentially, this is being used, as an early adopter from GitHub Copilot. So for those we've talked about in the podcast before, if you're not using it, it's awesome. It's like a little companion there in GitHub to help you as you're doing things like code analysis, optimization, things like that. So this is a model that's being used for that, as well as some of our cognition services. Obviously, this still follows our commitment to responsible AI and safety. So it talks a bit about that stuff. And basically, you can try out these models, today. So pretty neat thing. I mean, there's a whole list of models now that are available in there. So if you're using Azure OpenAI service, you have the option when you do your deployments to basically pick from a whole slew of those in there. They vary by region, but basically they all kind of have their little kind of niche around like what they're trying to kind of help with. I think these O1s specifically are around reasoning, more advanced reasoning and solving more complex problems. So yeah, that's the kind of model for those. I think the thing I've been experimenting with this too is like if you can look at the parameters that are being fed into these things, some of these are millions or even in the billions of parameters that can be fed into them. So it's pretty wild what they can do. So that's the first thing. The second one is a little bit different, not about AI, but around networking services. And this is some enhanced security and observability for AKS. We talk about AKS quite a bit on the podcast, and this is specifically around a new product offering called Advanced Container Networking Services. And essentially what this is allowing you to do is get insights into your network activity on your Kubernetes cluster, a bunch of different kind of more advanced networking capabilities around that. So I won't get into the details here in the interest of time, but there's a great blog we'll put in the show notes around this that talks through that. That's all we got.
Thank you. Yeah, so I picked out quite a lot. I mean, I did a scan of the Azure updates on Wednesday, thinking we were going to record an episode then, and there were quite a lot of new updates. And just today, a whole load of more seem to have got announced and dropped yesterday. So I've got quite a list. But I'll skip through the ones that I kind of picked up on that I thought were interesting. One is the GenAI gateway, which is some extended features within API Manager that are specific for when you're talking through to OpenAI on the back end. So it's a way of kind of easily integrating or getting some more value out of that gateway. And you can do things like token limiting, so throttling calls based on the number of tokens, or emitting metrics so that you can again get information about tokens that are coming to and from the models really easily. So you can just create one line in policy that will dump out that kind of information. And the third policy is about caching, so that you're obviously saving some more money and being a bit more efficient in the way of in which you're making those calls to OpenAI. So I think that was announced a while ago, and in public preview now is a further set of expanded capabilities. And I think from what I'm reading, this is just more about supporting a wider range of LLMs than was initially there. And while I was reading it, I came across this thing called the Azure AI Model Inference API. And that seems to be a way of standardizing the way in which you can communicate and talk to large language models so that you can kind of do it in a bit more of a standard way and not have to learn the specifics about the exact LLM that you're using. I thought that was quite interesting. Outside of that, I've seen 3 Logic Apps updates. So Logic App is our kind of way of being able to do serverless workflows in the cloud. And there's a nice designer in Azure in the portal as well for doing that. One of the additions is template support. So it was public preview again, but a way in which there's some pre-built workflows that you can just click on to kind of deploy an out-of-the-box scenario of integration. So maybe simple data transfers or some event-driven processes, but there's a set of templates up there that you can use for that now. The second one was a set of out-of-the-box monitoring dashboards for Logic Apps. So these are kind of curated visualizations that have been built in there. So there's some nice dashboards that give you this view over all your Logic Apps environments, so you can see what's going on a little bit clearer and better. And what was the third one? Oh, the third one was around AI again. So this is a low-code RAG ingestion with built-in document parsing. So what I understand this to be, RAG is the kind of retrieve, augment, generate model that's quite common amongst OpenAI use cases, where you're trying to go off and discover stuff using semantic search, retrieve a document, and then you're augmenting it with information and prompting, and then you generate the response back from that. It's quite a kind of standard pattern. And this is a built-in part of a feature of Logic Apps now, where you can add that as a step to make use of that AI to do things like document parsing and chunking within your Logic Apps flow. So I thought that was quite cool. And the other 3 were an addition to Azure Container Apps now to support Java. So that's now generally available. So using Java managed components for app-to-app communication within there. So Spring Boot admins included, dynamic logger, and embedded Java metrics in Azure Monitor as a result of that as well. And the Azure Application Gateway v2 has now got a basic SKU in general availability. So if you don't need all of the features and the throughput that the existing SKUs give you, there's now this basic SKU which has got a bit of a bit more of a focus on small and medium-sized customers. So lower traffic flows, hasn't quite got the same SLA as the higher SKUs, but that's another option, and obviously it's a bit more cost efficient as well. So that's it from the updates, I think, for today.
I have one thing.
Oh, sorry, Cynthia, go ahead.
So August 31st has passed. That means Azure App Service Environment v1 and v2 is officially retired. So if anyone is still on that, please go move on to ACE v3 to not experience a number of disruptions in the services, and there's a number of different documentation that help you with the migration process. And kind of following up on what Russell was saying about the RAG ingestion for Logic App, it's also really cool that you can connect to endpoints like REST endpoints or Blob or SharePoint directly, that instead of uploading the document, you can already give it like a document source, which I thought was really cool.
Thanks, Cynthia. So, Willie, over to you. I hope I introduced you correctly. I might not have got your team name correct. So if you can explain a little bit about your role and kick off the topic, that'd be great.
Yeah, awesome. Thanks for having me. So my name is Willie. I work in the consulting services side of the business, so the parts of Microsoft that does paid engagements with customers. And I've got an interesting role. My role is really to look at patterns and to understand what we do with different customers globally, and not just from a consulting services perspective, but also from some of the other delivery engines in Microsoft. So there's a couple of organizations in Microsoft that do kind of development work with customers, and I look at those patterns and I look for what is kind of consistently repeatable in those patterns. So ultimately, I will package up those repeatable patterns and make them available for teams to be able to reuse. I run an initiative called Data Science Toolkit, which is how we package up the code assets of those patents, and then I do a couple of other things internally around the solution offers and the things that we sell from a consulting services perspective. So that's kind of where I fit in. I've predominantly focused on AI and machine learning. I've been doing this for about the last 5 years in Microsoft. Before that, I was a solution architect. I drew, like I always fondly refer to it, boxes and arrows. And I help customers solve complex problems. That's kind of how I fit into the big machine that is Microsoft. Cool. Do you want me to just carry on going? Or do you want to ask some questions?
I'm curious to start because so many different companies and probably the customers you're working for are looking to adopt AI. But in terms of what is a good approach to think about something that they could actually benefit from AI, and what is kind of that thought process you've seen or gone through with the customers?
Cool. That's a great question, and it's got a bit of a long-winded answer because it varies a little bit depending on the customer, right? But simplistically, I've been involved with a number of fairly complex AI engagements where the customer has what we would refer to a transformative ambition of changing something in their business, and they want to use AI as the mechanism to make that change happen. So I've been doing work with customers that are very focused on sort of efficiency improvements and making sure that they can optimize and reduce the time it takes for them to do activities within their business. So if you think about the very standard sort of contact center kind of use case where we use generative AI to help answer questions that the contact center agents would have to look up in an FAQ or in a knowledge base, or that kind of fairly simple information extraction summarization type use cases. I've also been working with customers that want to transform their customers' experience, right? So kind of thinking about how do they enhance their products and services in a way that will attract new customers and grow their business from a revenue perspective. So I think the very first thing from an AI point of view is that having a very clear objective of what you want to achieve is generally a good idea. And we see that customers that have that very clear objective are more likely to succeed with what they're doing from an AI point of view. And the reason why that sort of clarity of objective becomes super important is that in the world of AI, and especially generative AI, there's a large amount of experimentation and innovation. So what that means is that we will iterate and we will experiment to see what's the best approach, which use case is feasible, how can we actually make this scale into production and kind of have hundreds of people use it or thousands of people use it. And if you have a lack of clarity in terms of what your objectives are and what are the results that you're trying to measure, it makes it really difficult to know when to stop experimenting. So you end up with customers doing a lot of POCs, and they never get out of this POC kind of situation because they don't really know what the outcome is that they're trying to drive and how to measure it. The clarity is missing, right? So, the very simple example I always use is if you summarize a document with the generative AI model, how do you test if the summary is accurate? I mean, if you had to ask 2 people to summarize a document, you'd get 2 different summaries as well. So, and so the question then becomes is we can measure the usage of that summary and say, hey, are people finding it helpful or not? And we can kind of we can start quantifying that. And maybe that measure is good enough for the objective, maybe it's not. And then we can iterate, right, to make it better. So I think having that clarity of objective, having clear objectives that we can measure and outcomes that we can drive towards all become really important for customers to be successful from an AI point of view.
Yeah, following on with that, I had a question if you've run into this, something I've struggled with a little bit. So coming from an engineering background and working on actually engineering products and things like that, everything's kind of much more deterministic. And when we have these AI models and we have these different new types of applications, sometimes it's very difficult to test. To your point about like quantifying things, I don't know, as far as like frameworks or how people are getting their head around that, because if you ask an AI model a question now and then ask it 5 minutes later, it might not be exactly the same, right? So it's like, how do I actually know, other than what you just said, like, are we saying, well, that's still helpful, even though it was a different answer? I guess to drill into that a little bit more, that from a software engineering perspective, it's like, hey, I asked a service to do this and it gave me this thing, and I know for
Mhm.
sure that's right. That's how I test it. But then it's like, well, this is not the same. It's different.
So I'm going to start at a very high level, kind of almost philosophy, and then I'm going to give you some practical examples that might be a little bit more executable, right? At the very kind of philosophical level is there are use cases where non-deterministic outputs are useful, and there are use cases where non-deterministic outputs are absolutely not what you want. AI can't solve for everything, right? So if you have to have a deterministic outcome, and they become quite interesting, these use cases, then maybe AI is not the way to go, right? So in the world of medical insurance in the United States, if you ask a question to your medical insurance provider, they have to, by law, give you the same answer, regardless of if there's nuance differences in the question. So if I asked about some benefit in my policy and I phrase it in a specific way and somebody else phrase it in a slightly different way, the answer has to be the same, right? And so if I use a generative AI model to summarize the policy document and answer the question, that's not really a feasible use case because I can't guarantee that the answer is always the same. Now, there are ways to, now for the practical part. So there are ways to solve for that, which makes the non-deterministic part a little bit more deterministic. So the very simple thing to do is if you can get generative AI models to generate structured outputs that you can use to select the answer, you can test for that. So if I get it to write a SQL query that shows me a sales report, the SQL query will fail or it will pass, and I can test very easily if that query has been correctly formulated. What's hard to test is that the data from the SQL query actually makes sense, but the actual structured output is not too difficult to test. The other thing that large language models are quite good at, which is non-deterministic and kind of think about it as part of the question answering process, is they're quite good at understanding intent. So they can understand that the three different questions that I've asked, or the questions that I asked in three different ways, are actually all the same question. And then looking the answer up in a database becomes easier because I can validate the intent. So I think a lot of times, because of the non-deterministic nature of this problem that we have with generative AI models, and because we see these cool demos that look like magic, we don't think about breaking things down into steps, right? And if you start thinking about questions and answers, there are actually a couple of steps involved in a question and answer, right? So first understand what does the question mean, then look for an answer, then validate if the answer is correct, and then serve it, and then probably ask if this was good or not, right? And so if you break it down into those kind of steps, then there's parts of those steps that are, or that process in the steps that are deterministic, and there's parts that are probably not so deterministic or non-deterministic and would be helpful from that perspective. So I think often we're guilty of thinking of not at a granular enough level in terms of the steps that we need to follow. But we're thinking about it as the model will solve all these problems for us in one go, and it doesn't, right? I don't know. Does that help you answer or does that answer the question? I was a bit rambling there. Okay.
Yeah, it's a really interesting point. So you're basically highlighting one of the points that this new way of working, new AI models, it's a different challenge for engineering teams, customers to adopt. How do they test it is one part of that journey, I guess. How do they prove values? I see in my customers as well the same thing happening where it was, ChatGPT came out, everybody wanted to do proof of concepts, and you start to question why are you doing that? What's the value in that versus, something that could really make a big difference. So those differences between traditional ways of working and how people need to change now and adapt for Gen AI, that's the piece I'm really interested in, and testing is a big part of that. Are there kind of test tools available now for customers to take advantage of, to be able to help them work in that new way? And what else do they need to understand to be able to get from where they are today in maybe a proof of concept or a pre-release version to actually, my business needs to support this as a business critical component?
So two pieces to that question. So I'm going to answer the testing part first. And again, I'm going to tell you sort of a little story to kind of illustrate the point. So when we want to test what comes out of large language models, the very first kind of human way of thinking about this is we all played around with ChatGPT. We all asked it some stuff, and then we validate by looking at it and go, this looks right, or no, this answer is completely wrong. I actually often get data scientists correcting the summaries I make of their code repositories in the Data Science Toolkit. I use ChatGPT to write a summary about what their code is, and then I send it to them and say, check the summary and tell me if it's correct, and they always correct something, right? They never just say, yeah, this is perfect, right? So human validation kind of works, right? And it's quite important to have that human validation, but doesn't scale so well. So what we did with a number of very successful projects is we have sort of 3 levels of testing, right? So if you have, let's say the document summarization use case where we have a whole bunch of unstructured information, we ask the model to extract, summarize, and answer questions about these documents, very standard type of use case for many different kind of patterns around that. But first step is we need some kind of ground truth, some kind of golden copy or basic thing that we can compare every iteration of our solution against. So in the case of one specific customer, we created 10 or 20 human summaries for some key documents that will always be in the data set. And then every time there's an update to the code or a version release, we run a comparison with the new version's summary capability against the golden ground truth version of the summary. So it's kind of like unit testing, maybe a bit of regression testing around that. The second level after that is to ask the model, is the summary correct? And interestingly enough, if you actually make the model do the summary and then ask it if the summary is correct, it's equivalent to getting a human to check it. If you scale that, it becomes kind of equivalent. So second level is to always ask the model to check itself. And then the third level is to get the human feedback. But the third level with human feedback is you get feedback so that you can keep the record of the feedback, which means that if I have a little thumbs up or thumbs down button that says, yes, I like the summary, or no, I don't, and maybe a reason why I didn't like it, or what was wrong with it, I can capture that as telemetry. And what that eventually becomes is a labeled data set, right? I've got a question and an answer and a label that says it's good or bad. And that labeled data set, I train a classification model with, traditional machine learning classification model. And then all my future iterations, I run through that model before I serve up the answer. So I can then say, large language model, is your summary correct? And if the large language model says yes, I run it through my classification engine. And that will check if it is. If it's not, it'll rerun the query. If it is, that will serve it up. And so I get like 3 layers of validation coming out of that simple use case of I check my summary if it's correct or not, right? And so I think that was probably one of the best learnings we've had, because that gave us the best results that I've seen, at least from my perspective and from a number of places, is that you should have these sort of layers of validation, and you should always include some level of human feedback in that process. Ultimately, when you get to sort of robust systems and sort of, I'm now start talking about LLM ops more than I am about just the software development part, but you want to be able to automatically update the prompting based on that human feedback loop. So as the human feedback comes in and you run it through the classification, you want to be able to say that I've got 80% correct answers and 20% incorrect answers as a whole in my system. And over time, it's trending up or trending down. If it's starting to trend down, I want to automatically update my prompts so that I can change the trend and push it back up again. So that telemetry process of being able to measure and understanding if those answers are good or bad and capturing them and over time is really important, right?
And that process with that feedback loop and the human validation in there, is that something that should be built in that goes through to production as well, so that's just part of everyday work? Yeah.
So if we think about this notion of LLM ops or foundational model ops, there's a couple of words that kind of mean the same thing here, but it's this way to kind of think about the iterations of improving your solution and your prompting until you get to a result that becomes quite useful, and then capturing telemetry so that you can iterate the whole system and making it more robust and better over time as you improve your prompting and your embeddings and all of that kind of stuff. So you need to continuously keep getting feedback from the system, because it's non-deterministic. It will not you can't have a static measure of or testing of the solution and then leave it. You have to kind of continuously validate and continuously measure so that you can continuously improve what it's doing. Yeah.
And Willie, while you're talking about all these iteration, how should we think about the data aspect of how we get started from the beginning? And as we continue these improvements, how do we store, or how do we, I don't know, split these data in a way that makes sense and that makes it more efficient for these continuous improvements?
Yeah, so you see, this is where the architect in me wants a diagram, but okay, so I'm going to try and explain this without the diagram. You've got sort of a couple of things to unpack there. You've got the data that you use to give the large language model context so that it understands what you're talking about in the context of your business. And then you've got the data that gets produced as this model creates its inferences, and you validate and create telemetry and measure all of that stuff. The first set of the first set of data, the data that I'm going to give the model context with, is actually the very important piece, right? In the old days, we used to say garbage in, garbage out when we did, any kind of analysis or reporting, because generative AI generates answers. If you put garbage in, it creates more garbage and puts it out, right? So it like increases the magnitude of the garbage, which is a problem. So the very first thing is you need good quality, clean data. And that's non-trivial for large organizations to solve. And then you need a way to bring that good quality, clean data into the embedding, the context that you're going to give this model. This becomes even more of a critical success factor if you're going to fine-tune your own models, because then you need a good quality, clean, labeled data set, right? Which makes it slightly more tricky. But starting with just embeddings and kind of giving context, having good quality data is really important. So if you don't have a fairly solid data strategy and fairly solid way to, all the standard data platform things that people don't want to talk about because it's not as sexy as AI, but you need data quality, you need data cataloging, you need all of those capabilities, right? And that gives you the right data to answer questions with and give you, not just to answer questions with, but give you the answers that are more likely to be good quality answers, right? I had a customer in South America that had a bot on top of a bunch of credit card product information. And sometimes customers ask a question and get an excellent response. And sometimes they ask a question, they get a really bad response. And it was completely random. They couldn't tell. There's no pattern to this. And eventually, after lots of painful prompt engineering iterations, they found that the FAQ data set that they gave the large language model had duplicate questions, bad answers, missing answers, questions that were not specified in the right way. And so the quality of the data that they gave it was bad. So they got this kind of weird performance happening with it. So it's really important to kind of think about it from that perspective as well.
So all that stuff you've talked about, that's kind of in the control of the team that's building the app and looking after the data and what have you. But one thing that we see is these models, they're getting updated, they're getting superseded quite frequently. How do we deal with that, and how do we test that the model, the new version of the model, is doing what it used to do, or at least the way that I've written my prompt isn't now badly impacted by those changes?
We might have to have a deep dive LLM ops conversation, but essentially, very simplistically, you need a platform, and I think you touched on the APIM kind of OpenAI capabilities earlier during this conversation, but you need a platform that can abstract how you connect to the large language models with your application. And the reason why is because you want to be able to swap models, and you want to be able to load balance, and you want to be able to route traffic to different models. So if your application and your prompts that you're writing needs to be able to go to a different model, you don't want to rewrite your application to do that. You want a gateway that kind of points you in the right direction. And so simplistically, you need some kind of platform capability that allows you to route your queries to different instances of large language models. Now, we can host all of those instances in the thing called Azure OpenAI, but you still need to be able to route between models with your prompt engineering capability. So that's kind of like a foundational thing that makes it really important. And the reason why it's important is, other than models change frequently, is that a lot of customers, and it's natural as people, we go to the latest, greatest, best model and we try a use case with that one. And generally it'll work. And then we want to deploy it. What we don't do is go to the latest, greatest model, which is, by the way, also the most expensive, slowest one, and then try it with the one just before that and see if it still works, and try it with the one before that and see if it still works, and keep going back and smaller cheaper and quicker until it stops working. And then you know this is the model I should be using for this use case. And that's probably going to solve already a lot of your cost optimization and a lot of your latency issues that you might get down the line just by doing that, because you're automatically optimizing to get the best model for the problem that you're trying to solve. So don't just try and solve every problem with the best, biggest model. You need a way to iterate through different models. And that's why the AI platform capability that something like APIM brings into this kind of conversation is really helpful, because that allows you to switch these models, especially in development environments, where you can test against different models, see which ones are the most optimal for your use case, and then use that combination in production.
Okay. And yeah, thank you. There's a lot to think about, right? And that whole route to go to production. What have you seen in, you shared with me a document around a framework that's created about kind of proving value of AI and how to go through some of this process. And that, I guess, is based off your learnings and experience with doing this with lots of customers. What are the kind of the main gotchas that customers have seen on their journey that you think would be, if you were to give 3 pieces of advice, or maybe one top piece of advice to somebody who's going through that journey now, what would it be?
I'm going to give you one controversial piece of advice and then one practical piece of advice. How's that? The controversial piece of advice is don't just build stuff and hope the business will find value in it for you. Right? I've seen too many IT departments go, hey, AI is cool, we need to build something. They build it and then they hope the business will come. It never, ever works. It will fail. Yeah, simplistically. I mean, that's a very deterministic answer, but in my experience, that actually never gets anywhere beyond a POC. The other thing that's super important is that's sort of the controversial one. The tactical one is that you need end users to use the solution that you're building. I mean, it's kind of obvious if I say it out loud, but people have to use this thing. And so you've got stakeholders that are non-technical people that need to use the solution that you're building using generative AI. If they're not part of the conversation from the beginning and participants in the design of how that interaction works and how they want to understand it work and get benefit from it and all of that kind of stuff, you also will have a very difficult time of proving value to the business. Adoption is key. We need people to use this kind of stuff before we'll find any kind of value of it. So simplistically, make sure that your business stakeholders are involved all the way through the process so that they can understand not just how it works, but especially because it's non-deterministic, how good does it have to be, or what level of quality of answer does it have to produce before they can trust it and use it? And that helps you a hell of a lot when you start iterating and developing. I think that's super key. And then at a sort of technical level, set up an AI landing zone with the gateways, with those capabilities to start with, because you want to be able to iterate, you want to be able to switch between models, all of that kind of stuff. And very simplistically, that landing zone needs to have a data service, a way to bring your data in. It needs to have a way for you to experiment, an experimentation service of sorts where you can kind of iterate through different prompts and embeddings and combinations of those. It needs to have a deployment service, a way to get your solution from dev to test to prod. And it has to have telemetry, monitoring. You need to want to understand what's happening. So if you have those 4 boxes on your platform, data service, inference, deployment, monitoring, I think then you're setting yourself up from a technical point of view, to be able to succeed and do all the things that I've been kind of pontificating about around, getting your users involved, measuring the output, measuring the value, all of that kind of stuff. Right?
Cool, thank you. And I guess the last kind of question from me is a lot of customers that I talk to, they're really keen with the AI adoption bit. They're happy with using the API manager to talk to the OpenAI gateways and all the rest of it. They can do all that bit. But then as it kind of gets closer and closer to production, they get more and more worried that there's something that they don't understand or something they don't know. And suddenly one day they're going to release this thing into production, and everything's going to go haywire because we didn't know about something that we should have known about, and we've switched it on. And now how do we get back to normality from this? Is there something that they need to is there like a checklist of everything they need to consider? Is there, I guess there's the responsible AI stuff, and we've got a toolkit around that. There's all the human validation piece that you've talked about, but is there any kind of secret source or something that you've seen maybe people have tripped up on that we need to kind of warn people about, or is it an unimaginary risk?
No, so I think there's right at the beginning of this process of building out a solution using generative AI, there's this kind of, I've been kind of talking about experimentation and feasibility, and I've kind of glossed over them. But what's really important is that when you are evaluating the use cases that you have potentially identified to solve with generative AI, you want to kind of stack rank those use cases based on 3 different kinds of ways of looking at it. And the first way is to kind of understand what's the value for the business and kind of figure out which is the most valuable use case, which is a very standard way of doing that kind of stuff. The second thing is you want to be able to understand the feasibility of the use case, compliance, risk, what could go wrong and what's the impact of that. Those kind of questions become super important to answer, especially in some industries. It becomes even critical to answer before you even start. Then you want to understand the viability. Do you have the right data? Is it the right amount of quality? Is your data AI ready? I think it's the buzzword we're using now. And kind of think about, is this likely to succeed if I actually embark on a development project and put this into production? And that requires some experimentation. You probably want to go mock up things and build it and see what it looks like and that kind of stuff. So you're going to kind of think about the value, the feasibility, and the viability of the use case before you start and getting it into production. The fourth thing, which I've only seen 1 or 2 customers do, is add a 4th dimension to that called desirability. And quite simplistically, if the board of directors say they want the use case, desirability is 10 out of 10. And if it's middle management, it's 2 out of 10. So that's just kind of a way to play the politics of the customers. But feasibility and viability is super important. We don't normally do that with software engineering, but we have to do it with generative AI. So that kind of starts you off in the right way to make sure that you are more likely to succeed than not. And then the next piece is a little bit difficult, which is you got to take it a little bit slowly and you got to iterate and scale in your scale. So one of the very good customer success stories of the recent past is they started with an R&D use case for product formulation, and they had to ingest a bunch of documents to understand formulas of products and all of that to come up with new ideas for new products. And so the first iteration had 1,000 documents. The second had 10,000. The third had 120,000. And so we kept scaling, but by release. So you do a smaller release, you grow it, you find out what the risks are, you manage them, you get to the next iteration, etc. And it's the same if you're going to roll that out to external facing customers. You might want to try that with internal users first, then get to a subset of users. I can say this out loud because it's public. Mercedes-Benz did that when they put ChatGPT into the S-Class Mercedes. The first iteration was S-Class Mercedes drivers in London. Only then. It took 4 minutes to get an answer. The second iteration was the whole of the UK. Went down to seconds. Then they started rolling out country by country and then globally. And so they did a kind of gated release process so that they can learn and improve the system and scale all at the same time, right? But you don't just go, bang, here's your solution. Good luck. Yeah.
It seems like what you said earlier is kind of important there too, like the feedback loop or the telemetry, if you will. Like once you start releasing this stuff and you start scaling, you still need some feedback loop there, right? Because it's not perfect, right? No app's perfect. It doesn't matter if it's AI or not, right? So
you
can't cover
fire and forget, right? You can't just leave it, and you have to kind of, it's a continuous process. And I think that's the biggest learning, is that this isn't a build and deploy application kind of solution, right? It is a continuously tinker with it and make it better kind of solution. It's very close to what we would traditionally have done with ML ops and kind of monitoring machine learnings for drift and for data drift and that kind of stuff in the past. Now you've got to kind of monitor the output from these models and validate if they're on track or not with their answers.
Fantastic. Well, thanks, Willie. That's been super useful, really interesting, and yeah, on point and on topic to all the kinds of conversations I'm having with my customers at the moment as well. So really grateful for your insight. Any last thoughts you want to leave?
No, thank you for having me. I really appreciate it. I've got a couple of links to sort of public open source material around this topic, which I will share with you, and you can publish as part of the podcast. And yeah, it's just been a pleasure. Thank you. I appreciate the time and the conversation around this.
Thank you. We'll put those in the show notes when we publish. Thank you very much.
Awesome. Thank you. Take care.
Thanks so much.